So thanks a lot for all to be here. So I'm going to talk about three things. One is about conversational agents, one is about robots, and one is about the efforts that I and the team started kind of 2 years ago to put these things together. So yeah, Naver Labs Europe, we are based in Grenoble. That's our place. It's an old chateau outside of Grenoble. And we are working on these what's called ambient intelligence, the idea of bringing the digital intelligence into your physical life. And this is the only advertisement I'm going to do. We are hiring, so if you're interested, go to this website and look what is out there. Even if you're interested and there is not one specific job advert which matches to you, don't hesitate to reach out. We got acquired by Naver 3 months ago. And since then, we are growing a lot, so there are plans of expanding the center quite a bit. So let me, right, and this is the important part at the beginning. So this is joint work with a number of different people. All the ones here with a formal picture are employees at the center, and Ankur is a PhD student from the local university. So three things. Let me start talking about conversational. I guess you all know that it's a big thing going on in artificial intelligence. It's a target of natural language, of understanding language, of focusing on trying to interact with a person based on text. And this comes back to this seminal paper, the paper which started artificial intelligence in the 50s, 1950 by Turing. And so he talked about computing machinery and intelligence. He made the remarks that measuring intelligence is not a well-defined concept. And then he said, okay, let's try to imitate this with this what's known as a Turing test. This came back, let's say, 2 or 3 years ago. There are some of the leaders in the field who have made this statement that language is the next big barrier, and you know that everybody is kind of all big research arms of the companies are working on these things. I have to say, just keep alert on what's called group thinking. If you see a whole scientific field, everybody saying the same thing, there might be of these group thinking going on. But it is a fact that dialogue is an important part of what computers can allow us to say. And my favorite quote is not from the previous people, but from Douglas Adams, a guy from Hitchhiker's Guide to the Galaxy. And in this foreword of a book, which is based on a game that he did, his idea is that he realized when he saw the computer that these were the right tools to come back to this original idea of interactive storytelling. And my focus here is on interactive. The idea is not just I tell you a story, but you can interact with the story. Now, if you want to focus not so much on the big AI hype, I focus more on the specific problem of natural language processing. Dialogue is one of these problems which you could call NLP complete. So it's one in here we have a computer science background. You know this concept of an X-complete problem is a problem which belongs to a specific class X and which is as hard as any of the problems in X. Okay, so you have space complete, NP complete, etc. So NLP complete is not a formal definition, but the idea is that you have a problem which is inside NLP. And if you solve the problem of dialogue, then you have to solve kind of all of it, NLP. So at least you have to solve these things which are here. That's natural language generation. And if you add multimodal dialogue, then you also have to focus on the speech, on the prosody, on the co-verbal. I will come back to this later on. And in addition, you want these to be efficient. So I'm not sure if dialogue is going to solve artificial intelligence, but if you solve dialogue, I think you can argue that you have solved a big chunk of NLP. Now, existing dialogue systems can be classified in a number of different ways. I prefer this one classification. I'm not going to talk about what's this rule-based systems. If you ever had the misfortune of calling a company and you have an IVR which tells you, say, booking if you want to book a ticket, say reimbursement if you want to get a reimbursement. What's behind is probably a format which is called voice XML, or it's another markup language which is called AIML. Basically, you encode all possible ways of saying something, and then you go down in your tree. Another one which is very popular are these end-to-end systems, which obviously you solve with a neural net. So you have the text as input and you produce a text as output and you don't encode anything. I won't talk about these things. I have a bit of backup slides in the end to show a bit of the work we did on this. But my focus is on this middle approach, which is modular approach, which is the one which has been the most successful and is being used in most applications. So let me dig deeper in what is this modular approach. The way that you normally, the specific component of a dialogue system, the ones I'm going to show here, you have the human who starts speaking, you have the first module, which is automatic speech recognition, which transforms the sound into natural language text. You then have a component which is natural language understanding, which takes the unstructured text and provides you a structure. And then this structure depends on what you're looking for. Most of the time it's some variant of first order logic. It can be a structure, a table, or whatever. In this case, it is a logical form, which tells it that you have an action of form in form, and it has two variables. One is a task and one is an entity. This structured form now feeds into the brain of your dialogue system, which is called the dialogue manager, which based on a knowledge base, based on the current dialogue state, produces the next action. Okay, that's the sequential decision problem. And it produces the next action again under the form of a logical form. In this case, the logical form is request something of type food. This feeds into the natural language generation part, which is the inverse of the natural language understanding part, which takes in structured form and outputs natural language text. And this goes into a synthesizer, which brings us back to the human. And of course, it is dialogue, so you iterate about these things. Okay, so this is kind of what's mostly used in academic systems. Now, this has been sold since at least 15 years, at least. I think most of you are familiar with the Gartner hype cycle. I think if you work in business models, kind of things, you're familiar with these things. So here you have at the peak of inflated expectations, you have the intelligent agents. And this is the pop quiz I like to do with this slide is, from which year do you think Gartner published this specific hype cycle? That's a real question, not a rhetorical. So you can look at the different technologies. So you're all familiar with this, right? So Gartner says you have these 5 stages of technology, and then they put every year, they have produced a number of these things, and they put technologies on the different stages. So any guess? You're way too young. These names doesn't say anything. So 80s. 80s, okay, this was the earliest. 60s, oh, 90s. So 60s I never heard. Okay, this is 1995. Actually, it's the first one I ever produced, okay? And what I said, what I find funny is this intelligent agent is here. I think nobody here remembers Clippy, right? So Clippy was an agent from Microsoft Word, which was supposed to be helpful. It's a typical example of something which is extremely annoying. This was 2 years before. So the big question is why last year, was 2016, and this year still people are talking so much about chatbots. I think there are at least 2 reasons why this is becoming so popular now. One is that people are used to communicate with text, okay? We all communicate with WhatsApp, with Messenger, with Line, with whatever. So we are already used to communicate with other people and with services on a text-based interface. And then entering a chatbot there is much, much easier. And the second one is that there are very easy to use tools out there produced by many different companies, which allows you to produce these chatbots, even if you're not an expert in programming. So I put a few ones here. Some moment I just stopped adding stuff. So you have Alexa, you have Amazon, you have Google, you had Baidu somewhere, I think it's hidden here. The IBM one, these 2 are French, Naver invested Snips, and this is the one of Line, Baidu is over here. So they're all roughly the same. It allows for domain experts, which are not technical experts, to take these tools and to try to program their own scenarios. Now, these scenarios are a bit simpler than the modular one I have showed you before. Most of them, the blueprint is the one you can see here. So there are 2 things you have to do. The first one, based on the first sentence you say, you recognize what is the intent that the person is trying to do. So do you want to book a taxi? Do you want to reserve a hotel? Do you want to get a pizza? And once you enter these things, you have different scenarios. And each one of these scenarios is a slot-based scenario. So there's a number of different predefined variables that you have to fill. And then the role of the dialogue agent is just to fill these things one by one. And once you have filled them all, you can launch an application which is next to a database or whatever. So just to get the names right, these ones here I call action services. These things are slots, and in the end it's what's called a fulfillment. And very few of the services I showed before, some of them do, but very few of them do this in an interactive way. So this is the one shot. You have one query in mind, you hope to get the right scenarios, you fill in your form in the form of natural language, and you provide the fulfillment. This is basically what's the current state of the art for commercial application of Dialogue Manager. So I will pause here. I will go to the second no, sorry, this was of course important. So before becoming Naver, we was with Xerox. That's because you will see the logo out there. We did a very similar things than everybody else. So you can see you can annotate the different intents here to create different intents. You create different entities, and then you can annotate these things. You have a sentence, and then the system says, I think this is a request meeting information with 92% of probability. And then you can mark, for instance, here Carl Smith and say this is a name, and you train your model like this. Okay. I want to go to the second part, which is about the status of humanoid robots. I'm going to be a bit quicker on this part here. I'm less an expert in this aspect. But in general, in the robotics community, there has been a trend from what would be called robotizing humans to humanizing robots. So if you go to a car manufacturer these days, that's what it looks like. You won't say any humans. You have all these machines which produces, especially in the beginning of the manufacturing, it's mostly done by robots. But something which is very interesting here is that I'm not sure you can see there are walls here to the left and to the right. Okay, these are called robots in a cage. So no human is close to the robots. Actually, as soon as a human enters, there's an alarm going on and everything shuts down. These things are, of course, very dangerous. There is no safeguard that it won't kill a human. What currently people are investing a lot on is what's called cobotics. It's the idea of having industrial robots working together with the human. So there's a huge jump here because now there is no wall here between the human and the robot. And the idea is that the human does one part, the robot does another one, ideally parallel, if not sequentially, but they're in the same physical place. And then you all have heard, I guess, about these social robots, robots which can be together with a human and which has a more social purpose instead of an industrial. And you can see more and more of these things actually being sold and trying to be put into the places of people. And this one here is called Nightscope. It's an ex-Xerox person who founded this company. If you go to a Hilton, I think in this case in California, you can say, I want a Coke, and instead of somebody going up and bringing us a Coke, it sends you a robot. The robot communicates with the lift, it goes up, it finds the right door. As soon as the door opens, it's assuming it's you. There's no facial recognition. It opens its locks, it gives you the Coke, it says, can you accept that you got whatever you want? And it goes back, okay? It's basically concierge, some very easy task. A second one is this one, it's called Nightscope. This is Savioki, I'm sorry, this is Nightscope. It's a surveillance one for parkings, and it detects suspicious behavior, whatever this means. I guess it's broken glass. Now, what is interesting, and then okay, now you have a Jibo. You may have heard of these things. They've been 2 years ago. They had a Kickstarter company. Now you can buy one for a couple of $100, I think. And now, what is funny between these things here, Jibo is a bit different, but between these two, and I talked to the founder on Savioki, and I asked him why is there no face on it? Why can't you talk to it? He says it's a very concrete design decision they had to take away the face, because as soon as you see a face, you think you can start interacting with it, and the technology is not there yet. So in order to discourage you to start talking to the robot, they just take away anything which looks human-like. So these are things which are actually being sold and are in pilot stage. I don't think they're working at pilot stage. And then on the other hand, you have these humanoid robots which try to be being useful. Many of them are, the pictures are going to be from Aldebaran. This one was piloted in Darty, this is in Carrefour. This is in a cruiser, and this is at SNCF, at the train station. And these pilots, normally they last a few weeks, and then it's a wow effect. Everybody goes there because they heard that the real store actually has something cool you can't find on the internet, and then they go to the store. But it's not much longer than that. And this is another one. It's another company. It's a Catalan company called PAL Robotics, and they also produce humanoid robots. Now, these things, these ones, the humanoid robots, they don't last very long, as I said. They last a couple of weeks, and the wow effect is over. And actually, if you ever had the opportunity of talking to one of them during the pilot, or if you go to Japan and to talk to them, you will soon realize that the natural interaction they have is very, very bad. And the reasons are twofold. One is that there are what's called keyword-based ASR, at least until recently. This means that they don't do a full-fledged speech recognition, but they look for some keywords in order to trigger their actions. There is no real dialogue management. It's just a very simple tell me a joke, what's the weather, etc. And the second reason is that, and I like very much this one here, it's the guard, because you can see how these robots are used in reality. Actually, the main interaction from the human to the robot is done by the screen, and then the robot just says something or shows something. But the voice is only a secondary challenge, and the main challenge is the screen. So everything encourages you to use the screen and not the voice. And then the question is, why can't you combine them? And I think, my hypothesis, and that's what I'm going to talk about in the last part of the talk, is in order to combine these things, I think we have to learn the lessons from the chatbots, where we have seen that in order to make them popular, you need tools which people can use, which are not experts of the underlying technology, but which are experts of the domain, which help you to create these scenarios, because totally open dialogue, the technology is not good enough yet, but which allows you easily to create scenarios which are robust enough and which does all the training under the hood. So let me say two very, very simple things we did into this directions. We don't have any toolkit, any software development kit in order to allow you to do these kinds of things, but there are simple steps that we started doing in this direction. The things I wanted to show you a video, and the title of the slide is called Expectation Management, because maybe you're a bit more familiar, you know what can be expected, but many times people have very high expectations, either because they saw some movies or they saw some demos which were scripted and which they believe are actually true demos. So I'm going to show you one demo, and this is totally automated, so there is no human behind. No, it's not Wizard of Oz. There's nobody controlling it. Just to give you an idea of what is currently feasible. This was 18 months ago, I think.
Hello, welcome to CART headquarters. How can I help you?
Hi, my name is Anna Thompson. I'm here to meet Bill Johnson.
One moment, please.
Okay, no problem.
What company are you from?
I'm from Conduent, Conduent.
Thanks. I hope you're not in a hurry, Anna.
No, not at all.
I understood Conduent. Is it correct?
Yes, that's correct.
At what time do you have the appointment?
It is at 10:30.
Okay. Now I need to think a bit.
Okay.
Could you confirm, please, that you have the appointment with Bill Johnson? The appointment is scheduled for 10:30. Your name is Anna Thompson and you are from Conduent?
Yes, that's correct.
Give me a second, please.
Okay.
Thank you for confirmation. I will call Bill Johnson.
Okay, thank you.
Hello, Bill. This is now calling. Anna Thompson is waiting for you at the reception. Do you want to leave a message?
Yes, tell her I will come in 5 minutes. Thanks.
Okay, Anna.
Yeah.
I just called Bill Johnson.
Mm-hmm.
Bill Johnson will come in 5 minutes.
Okay, thank you.
Now, could you please look at me? I will take a picture for the badge. 1, 2, 3. You can retrieve it from the printer next to me.
Okay.
Have a nice day. Goodbye.
Goodbye. Thank you.
Okay, so this is, again, expectation management, right? So when we were shooting this video, we had our actual receptionist just sitting nearby, and she was laughing all the time. She was very happy because she was sure that her job would be safe for many years to come. You don't want to interact with something like this. And I think that's the reasons why you don't see them more often in public places. This was 18 months ago. Things evolved a bit. But if you see something which is an order of magnitude better than this, then it's probably a fake demo. Okay, so this is basically what we can do with the current technology. So let me talk about, as I said, a few things we did. The first one, you already saw it in the video, but it was probably a bit hidden. Every time the person, so Ekaterina in this case, she said something, the robot had to think a long time. Okay, and the reason is that all this process here takes time. In particular, the speech recognition, especially if you do it batch-based, if you do it incremental, it might be a bit better. If you have something sophisticated, we did this, which was done on the cloud. This was done on a server on premises, but it was not connected, so it was wireless too. So these things, there is a lot of latency involved in this whole process. And there is this great psychological research which tells you the obvious things, but which actually shows that it's true, that passivity leads to boredom, and if you're bored, then you're not satisfied, okay? And then this is actually already the video you saw is the evolved version. In the first one, the robot was just standing there and not moving at all. And this is extremely annoying if you have a humanoid robot, because you have the feeling that it should be doing something, it's not doing anything. So this was done this research was done in general. If you have our idea, we didn't show this, we didn't run experiments, but it seems obvious that if you have this embodied agent, it's even worse, because as I said, you would expect an embodied agent to do something. Maybe not a screen, but it's something which can move and doesn't move is even worse. So there have been people, not surprisingly Japanese people, who have found the same problem. And their solution, what people have used in the literature, is just to emit one specific sound every 2 seconds. They used eto, which I understand in Japanese means I'm thinking. So basically, it's the hourglass movement on the screen. Right? It's basically something which is telling you, I'm thinking, hold on. We wanted to use a filler, something which could fill the gap of silence while the robot was doing the processing, which was multimodal, which was not only speech, but also the body movement, which was personalized, meaning uses elements of everything which has been said in the dialogue so far. It should not start a new frame. So this is a concept from the dialogue theory. It shouldn't start a new conversation. It should be something which is self-contained, because you don't want the robot to the human to act upon what it just heard on the filler. And lastly, it should fill most of the pause. So it should not be longer. It shouldn't be shorter, because then there is still a lot of time left where nothing happens. And the fun thing here is that you should do this without knowing the actual content of the last utterance, because the time to transcribe what's actually being said is actually most of the bulk of the time that you need in order to understand what's going on. So you only know that the person just said something, and you have to fill the pause in between. So what we did is we calculated the functions. It's just a linear function which, given the length of the voice envelope, so we know that you said something which lasts 2.3 seconds, computes how much time we expect it would take us to process, something which is done offline. And then we create this is done by hand. We create a list of these multimodal fillers. So this is text, and the parts in red are procedures which are executed, which are body movements, which were pre-recorded. The stuff in yellow are actually commands which the Naokai, which is the operation system of the Aldebaran robots, can interpret. So this changes the speed, and this adds a pause. And the blue parts, it's what we call personalization. So remember, we're in a slot filling approach. So what these fillers, they become active as soon as this specific slot has been detected with high confidence. Okay, if you don't have it, then this filler is not activated. The idea is that this gets filled with whatever is the value of the slot here. So it gives an idea of personalization. And then for each one of these fillers, we compute how much it takes to utter it. This is done in an automatic way. And then every time there is a silence, basically we sample randomly one of these things. It's not deterministically, and proportionally to the time it takes to fill it. So we don't want something which is too short, we don't something which is too far apart. And we did what you should do if you do this work in interaction, human-robot interaction. We tried to evaluate it with humans. So we pre-recorded 2 scenarios, each one with 3 strategies. One is where there were no fillers. One is where there were a filler which was just a recurrent sound. And the third one was our dynamic filler. And the question we asked people is a weird one. The question was, which one? So these were pre-recorded, right? So the people logged in into the evaluators, logged in into the web service. They saw the 2 screenings. And the question was, which one do you think, which one felt shorter, right? So we removed any indication of time. Why did we ask this indirect question? Because in the first trials, we had asked a direct question, is which one did you like more, which one was more engaging? And the dynamic one kind of won all the time. So we wanted to find something a bit more challenging. And the last point, so we asked for prospective duration. There's research shown that if you know that you're going to be asked something about time duration, you perform better than if it's retrospective, if you're asked about something which happened before without you thinking that you had to answer this kind of questions. So we ask people in our center to volunteer for these kind of things.